Find the length of the arc of the indicated sector in the figure and find the area of the sector. Well, to find the length of the arc, we're looking for the length of just this portion of the circle, and that's a fraction of the entire circumference of the circle, and we know that circumference is equal to 2 pi times the radius of the circle, or pi times the diameter of the circle. Well, in this case we have 2 pi times 8, or 16 pi, as the circumference of the entire circle. We're only supposed to find a fraction of that, and that fraction is given by the fraction of the circle that 45 is, compared to the full revolution of the central angle there of 360. So we can think of this, the arc length, which is often denoted with the letter S, arc length there could be written as 45 degrees out of 360 degrees times the entire circumference of the circle, which is 2 pi times 8, as we saw up above. Now if we simplify this, 45 over 360 reduces to simply 1/8, so you will have 1/8 of 2 pi times 8. The 8's divide out to 1, and we're just left with 2 pi. So the distance for S, for this arc length, is just 2 pi. Another way we can do this is to use the equation S equals r theta, where theta is in radians. That equation gives us the arc length of a circle with the radius r, and the angle being equal to theta. Of course, if we do that, then we need to first work out theta in radians. And so we had a theta of 45 degrees, but to convert that to radians, we need to multiply by the ratio between the radians of a circle and the degrees of a circle. There are 2 pi radians in a full circle and 360 degrees in a full circle. If we do this, our units of degrees will cancel and be left with just radians. Of course, the 2 pi over 360 could also be thought of as just pi over 180 in reduced form, and that's also a commonly used multiplier there for the conversion. What I'll do to finish this off is just divide out 45 over 360. That simplifies to 1/8, and that means we have 1/8 of 2 pi, which is just pi over 4. Again, 2 and the 8 now will cancel, leaving pi over 4. That's in radians, and so that's the measure of the angle, theta. So to use our formula S equals r theta, we would write S equals r, that's 8 centimeters, times pi over 4, and once again this gives us the 2 pi that we found previously. So that gives us the arc length. However we work it, we can see that the arc length is 2 pi. Now, we were also supposed to find the area of the sector. That's the area of that slice of the circle, and we could use the same argument. We know that the area for a full circle is equal to pi times the radius squared, and so we could compute that to be pi times 8 squared, which is 64 pi, and then take the fraction of the circle to get the sector. We know that the sector is 1/8 of the circle, so its area of the sector would be 1/8 of 64 pi. That gives us just 8 pi. If we like, we can also use the formula for the area of a sector of a circle. That's A equals 1/2 r squared theta, where again theta in radians, theta is measured in radians, and in this case that would give us 1/2 of 8 squared, and we've just found theta in radians at this step. That was pi over 4 radians, so times pi over 4, and simplifying, we see that we have the 2 times 4 is 8. That cancels out with one of the 8's in the 8 squared, leaving just 8 pi, as we saw.